Thank you all for joining today's CSCRS Research to Practice Bites session on pedestrian crash prevention systems in motor vehicles. So we're going to be hearing today from Dr. Asad Khattak, who is the Beaman Distinguished Professor and Transportation Program Coordinator at the University of Tennessee's Department of Civil and Environmental Engineering. He is also the editor-in-chief of the Journal of Intelligent Transportation Systems. We're delighted to have him here today to talk about his research. If you aren't familiar with the Collaborative Sciences Center for Road Safety, or CSCRS, our mission is to accelerate progress in reducing transportation-related injuries and fatalities by utilizing a systems approach, bringing perspectives from planning, engineering, public health, data science, and robotics to the field of road safety. We are one of two national centers with a designated research focus on transportation safety. We bring together staff, faculty, and students from different UNC departments, as well as those at our partner institutions you see listed here, UT Knoxville being one of the important ones. Just a bit of housekeeping before we get started. As participants, you're all going to be muted during the session today. You can submit questions in the Q&A box. And today's session is being recorded. CSCRS is going to make the recording and the slides available just a bit later. And one helpful Zoom tip before we start, you can choose the speaker view option at the top of your Zoom screen to optimize the screen of the current speaker. So that's all I have. I want to go ahead and turn things over to Dr. Asad Khattak. You can go ahead and bring your slides up whenever you're ready.
You can see my screen.
Okay, yeah, it looks great. Go right ahead. Thank you.
Thank you so much, Dan. And I am so delighted to present to you on the topic of pedestrian crash prevention systems. I'm also thankful to my co-authors, Beaman and also Anthora, who've helped me write this paper that I'm showing you on my screen here. Sorry about that. It's, I'm trying to get to right on the screen so I can share some thoughts with you as we go through my presentation. So with that, I would like to introduce the topic. As we have seen, fatalities and severe injuries of vulnerable road users have been increasing. 44% increase in pedestrian fatalities between 2010 and 2019. And also in 2020, about 6,516 pedestrians were killed in roadway accidents. A huge price if we put about $11 million per fatality as the social cost, then these costs are very, very high. And also we can enhance this mobility of pedestrians in this our transportation system by providing safer alternatives. And especially with technology advancing so fast, we should be able to provide that kind of system in the future. So how are emerging technologies improving the safety of vulnerable road users, and what's the potential? And I want to point out that although I'll talk about passenger vehicles, these systems can be multimodal, and we have done research on looking at how these systems could work in buses and also be connected, not just automated. This on the right-hand side shows us the safe systems approach that Dan was mentioning, where we want to have safe road users and also safe vehicles. I'll focus on safe vehicles, but I just want to mention that we have also been looking at pedestrian time to death after crash, post-crash response, this part here, as well as safe speeds and so on. So with that, I think I want to get into the crash prevention systems, which are also known as pedestrian automated emergency braking system or pedestrian collision avoidance systems, frontal pedestrian impact mitigation braking. And what these systems are they are basically sensing the pedestrian and then giving warnings or taking over control of the vehicle. And these are generally considered low levels of automation. That is, they do not have level 3 or 4 automation, but they are currently available in the vehicles that we can purchase in the later models. So Insurance Institute for Highway Safety did a fairly detailed study of these vehicles that are being sold, and also they provided ranking and ratings for these vehicles, which I will get into the details of. But they also have this data available, and we were able to get 3,095 tests of these vehicles, 91 different types of vehicles that were tested. So these are not connected with the infrastructure, but they are just in the vehicle. And the test scenarios that they ran included like children running into the road when they are obscured and darting out. And these were done at like 20 kilometers per hour and 40 kilometers per hour under two scenarios. The other one is just a pedestrian coming out onto the road, and if the vehicle can stop or not, which is this, and then finally walking along roadway, and that's also done at 40 kilometers per hour and 60 kilometers per hour. Those were the speeds at which they were tested. As you can see at the bottom, we are showing pictures of how these tests went. So what we were able to do was to access this data on 3,000 plus tests, and we also combined that with other attributes of vehicles in terms of their weight and price and so on. So we consulted other sources and brought in data. We integrated it, we cleaned it, and also we provide descriptive statistics and developed what are called random effect Heckman sample selection models with panel data to explore relationships of accidents that did occur and the speeds at which they occurred. In this case, these two equations are used, one of which, the first one is whether or not there was a collision, and if given that there was a collision, how intense was that collision? That is, what was the impact speed? So that is this equation here. And since we have a complex structure, which I can go into the details of at another time, but basically we have several vehicles and then several scenarios. So several vehicles, several scenarios, and then within each scenario, there were several tests done by those vehicles. So ultimately, what we want to do is to understand what these system performance is of these of PCPs, and also what are the correlates and the hazardous situations that are observed in the field. So this is basically showing us whether things were working or not well. So collisions with pedestrians occurred in 30% of the cases, but 70% of the cases, they were being avoided successfully, of course, at different speeds. As you can see, those speeds are shown here, low speed impacts, and also all the way to 40 miles per hour impact. Now, over time, things have been improving. If we look at model year and test year, for example, 50% is the average of what we show here in this data, and that, improved to 61% success rate and 77% and 81%. So over time, things have improved. Of course, if a vehicle is a test speed higher, then that is a major factor in the success. So, you see that it's at 37 miles per hour, only about 50% were successfully avoided and 50% did have a collision. So that's what the data is showing us. When we look at, given a crash, what is the speed reduction? We find that it's 50% reduction in impact speed. When for example, the vehicle is traveling at 60 miles per hour, the speed was reduced to 28 kilometers per hour. For 40 kilometers per hour test, it was reduced to 23 kilometers per hour, and so on. So So substantial reductions in speed are also observed, and that talks about safe speed. That is, these systems could provide a lot of potential, have a lot of potential for improving risk or reducing the risk. So if drivers do not brake, and that's an assumption, it's not an unreasonable assumption, because in other studies, naturalistic driving studies, we found that 72% of the drivers that were involved in collisions did not recognize the hazard. And that paper is a separate paper as indicated down here. But assuming that this PCP systems can substantially mitigate risk, how much does it mitigate risk? So like I said, for the 30% that did get into a collision, the impact speeds went down. So let's say if the person was traveling at 60 kilometers per hour and the driver was and hit a pedestrian, there's a 54% chances of a risk of fatality. This is a familiar figure, as you can see here, showing the effects of speed. And we did look at studies that have quantified this relationship. And on average, if you are traveling at 60 miles per hour and unfortunately hit a pedestrian, the chances of fatality are 54%, as shown in this figure. But our tests show that, if PCP reduces the speed to 28.1 kilometers per hour, then the risk here is 0.128, as shown in here. So that's what we are seeing, this risk. And this table just basically gives us the same numbers, but it indicates that we can have a substantial reduction. Okay. Now, in addition, we looked at different vehicle performance and speeds, and we looked at Tesla vehicles, since that's just one of the vehicles that seems to have a good automation system. At least that's the perceived by the general public, that they have good automation systems. So at higher speeds, Tesla Model 3 performed relatively well, but the collision avoidance in general in the data that we analyzed for IIHS was 60% collision avoidance. That's shown here. So at 60 kilometers per hour, we see that. But at lower speeds, as you can see, it's like also 60% and 67% avoidance. But other vehicles, for example, Audi A4 had better performance. They were able to avoid 100% of the collisions at that, but they were not able to avoid the collisions at all at 60 kilometers per hour. So now these, ratings are aggregated by IIHS, and they use different weighting factors for whether a vehicle was in a collision, and given that, what was the impact speed. And they have come up with, IIHS has come up with this kind of rating, which has motivated car companies to invest more and more into pedestrian collision avoidance systems, I think. But basically, they have this rating of superior and advanced, and then there are two other categories, which I'm not showing here. And what they found was that actually Nissan Maxima has the best performance, and it's not a luxury vehicle, it's just this Nissan Maxima, they point out is particularly good in crash avoidance. And if you can avoid the crash, then you don't have to worry about impact speed. And as you can see, Tesla is in the second category here. The model for which we are talking about the data here. Now, we used a different set of data. That is, we used a bigger set of data that was available on IIHS. For this rating, they have used like 5 tests per vehicle, and also they have used weighting, like, one of the scenarios was weighted more highly than other scenarios, which is that perpendicular motion of a pedestrian coming out. So with that, I wanted to just share modeling results. They are more discussed in the paper, but the maximum deceleration rate is important. And as you can see, this is the second part of the equation, which is basically looking at the speed. And the maximum deceleration rate, if it increases, that decreases the speed at impact, which makes sense. But the thing is that you cannot just get into this maximum deceleration suddenly, because the car is going to be perhaps rear-ended by another car if it's being followed, or the driver may be very uncomfortable if you just suddenly the vehicle algorithm starts to brake very fast. But in general, over time, we've seen that this deceleration rate has the maximum deceleration rate has dropped has gone up from 9 meters per second square to 11 meters per second square. So the car companies are adjusting their algorithms accordingly. And so also lower weight, large trucks are hard to control. So as within cars also, they are harder to control. And what we found was that, yes, if higher the weight, the less you are likely to be able to decrease the speed at impact. Okay. And then there are many other interesting results in here that in the paper that you could look at, like vehicle model year and so on. Over time, things have been improving. One other issue that I wanted to point out is that of nighttime crashes. So in real life, a 27% reduction was observed in one of the studies that IIHS has done. The link is here. You can look at it, not at the study, but at least at the results. For equipped vehicles versus unequipped vehicles, so they have an impact in real life situations. Also, injury crash rates are lower. Nighttime and unlit roads, there wasn't any difference. And given that 75% of fatal crashes are at night, and that is a problem. The technology that's being used is either single or dual camera, or camera and radar, or radar only within these cars. I think infrared is not being used in these vehicles, and that might be an issue. And also, they have different collision rates at low beam and high beam, because this is a vision-based camera system that we are talking about. So that is a very important issue to investigate further. I think, so I guess I'm running out of time almost, but his conclusion, the pedestrian collision prevention system technology reduces vehicle pedestrian crashes and fatalities and injuries. The performance has been improving over time in recent years, and also they are able to detect better and better and stop at lower speeds if there is an impact. They don't detect the pedestrian in 30% of the crashes, 30% of the cases, but in 70% of the cases, they were able to avoid such collisions. And for crashes, these systems mitigated the impact speed by on average, about 50%. So a huge impact that these vehicles can have. Also, pedestrian collision avoidance systems can mitigate the risk of fatality for pedestrians in real life situations, like I was showing you some of the data. Also, higher market penetration of these vehicles with these systems can certainly be something to encourage and a good for transportation system. In terms of future research, I would say we need to test these systems on buses, on large trucks, and also on other modes of transportation. Like I pointed out, darkness is a key issue, and IIHS has been conducting tests and designing tests for that. And as the data becomes more and more available, we will want to look at that. And finally, I want to mention this trolley issue, trolley problem, as it's called, where a car would have a choice of maybe killing the driver versus a lot of pedestrians, or taking the life of one pedestrian who is just maybe on a side road if a final maneuver can be made. But the point is that this may not happen or arise because of the fact that there might be no collisions. If we have higher and higher improvements in collision avoidance systems, we could eventually eliminate such even potential trolley problem issues. So I think this is something some more food for thought, where we could think of, okay, how to design algorithms and AI systems to recognize and be able to mitigate complex situations like this trolley problem. So with that, I would ask for any questions if they have come in.
Yes, we had quite a few. We'll get to as many as we can. And thank you, by the way, for this excellent presentation, and to your team for doing this work. A lot of the questions that came in, I think, they were something like, did the tests look at this issue? And so it kind of builds on some of the things that you spoke about needs for further research, but I'll rattle off a few of them, and you can tell us whether it's sort of been handled or whether that's something for the future and we need to look into this. So folks were asking about pedestrians who might have been in wheelchairs, and then building off that one, maybe shorter pedestrians, children, different shapes of pedestrians, maybe other than just a typical adult person. Anything there?
Definitely, yes. And luckily, IIHS has, in these scenarios, as you can see, and they give the example of Halloween, when a lot of kids are out and it's a little dark. But basically, kids have been tested in some of these scenarios, as you can see here. And also, I think it's an excellent point about people with disabilities and how they may be also part of these scenarios. So there are a lot of different scenarios that we can go into that are in real life scenarios that happen. I have done a lot of work on this, and dash and dart out, and people also lying in the street, for example, or playing in the street. Those are, believe it or not, some of the reasons for these fatalities. And we certainly need to design more and more scenarios around these unusual or edge case scenarios, where we can anticipate the different road users and how the system may respond to them. So yes, I mean, in one instance, they have tested it for the children, but not all the difficult scenarios that are encountered.
Okay, great. Thank you for elaborating on that. The few questions about whether any of the systems were available as sort of aftermarket products that can be equipped into other vehicles. And another person was asking, we're looking at sort of brand new, pretty expensive vehicles, and the question of, could this easily sort of be disseminated throughout the driving public, especially those who may be lower income and who may not be able to afford these, or there are cost-effective measures that could be then kind of put into vehicles that are already in the fleet.
Right. So let me see if I can answer some of the, at least partially, these questions. So yes, I mean, even though that these are more luxury vehicles, but as you can see, I did point out, and at least IIHS mentions Nissan Maxima, which is not a luxury vehicle, that they have this equipment standard in 2020. But aftermarket systems are available, but they too are not, not tested well, and they are iffy at best. The issue is that of camera, and also it's ways of warning, and like we said, I mean, these technologies are improving, and maybe we will have much better systems, but right now I'm not aware of a lot of aftermarket systems that might be available currently, with which are that kind of brings us to just maybe these new cars that are able to install these systems, and even they are, as we were saying, not really perfect. They're better than not having the system, but certainly there's a lot of room for improvement in those. So Dan, what was the other part of the question? Sorry.
No, I think you hit on a lot of it. I think that makes sense, but it is good to hear that, like, some of these vehicles are not necessarily what you consider to be those luxury vehicles that
Right.
that over time they'll probably will be able to better penetrate the market for all income levels, hopefully, or most income levels. I wanted to get to a couple more. We're running a little bit low on time. A few people brought up the vehicle size and weight issue, and you pointed that out in some of your tests, and it seems like there are a growing share of vehicles, at least in the US, that are large trucks, large SUVs. Are those vehicles getting the same sort of systems? I'm just quickly scanning down the list on this slide, for example, and these seem to be mostly sedans, smaller vehicles comparatively. But the bigger ones, may be the ones that are have the biggest risk in terms of that kinetic energy transfer.
Exactly. Yes, you hit it on the head. The kinetic energy transfer is the issue, and also their design has become more and more aggressive over time of the large trucks. So I think it's certainly these systems are becoming more and more available on trucks, as that is well, I'm not referring to the large trucks above 10,000 vehicle weight, but the tractor trailers. I'm just mentioning the trucks that we drive, personal vehicles, and so these systems are becoming available. But I think the issue would be that they're just not able to stop as fast as we were showing you, and as was mentioned, if the vehicle weight here is higher than 4,500, then the chances of them stopping are, well, the speed at which the impact speed is going to be 4 miles per hour, 4 kilometers per hour higher. And that is a problem, because if the speeds are higher, of course, and also the design is such that pedestrians get more injured by these large trucks, then that's an issue that we need to address. And don't know if anybody is looking at it and comparing these, but certainly IIHS has ranking for other vehicles, including trucks.
Great. Well, thank you for that, and thank you for taking time to share and also answer questions. We don't have time for more questions, unfortunately, but on your final slide, and the deck we will be sharing this out with folks, is your contact information. So we'll have that coming to everyone. We're on the final slide now, and this is our plug. Just wanted to take a moment, and there's Dr. Khattak's information. Next month, August 31st, we're going to have our next session. It's going to introduce you to a new platform, a new tool that you can use for understanding micromobility fatalities. We talked about micromobility on a previous webinar, and this might be right up your alley if you're interested in that topic. Kristen Podsiad, who's here at HSRC, also a school Department of City and Regional Planning and Public Health student working on this topic, will be sharing next month this platform and this new tool that you can use to understand these fatalities. So we hope you'll come back and join us for that. We'll send some information out. Dr. Khattak, thank you so much for spending time with us today, and thank you all for attending the webinar. We'll see you again next month.